Hi everyone, in this lesson we're going to be looking at transformations of exponential functions, and as you know from lesson 1, an exponential function is a function in the form of y equals b to the x. And so these are all the possible ways that we could transform the function, meaning we can move it up or down or left or right or stretch it or shrink it or reflect it. So I think this table is going to be a really important reference for you as we go through the graphing and writing the functions and so forth. So if we have a value that's to the outside the function, so we have some examples here. So 2 to the x plus 3, we're going to move the function either up or down. Plus 3 would move it 3 units up, minus 6 would move it down. If we have a function that has a value that's with the x value, so in other words, in an exponential function, it's in the exponent with it. So we have x minus 2 here. That means we're going to move it 2 units right, and x plus 1, 1 unit left. It's going to be the opposite. If it's a minus, it's going to go right. If it's a positive, it's going to go left. If we have a value in front of the function, that's going to be either a vertical stretch or shrink. If it's greater than 1, it's going to be a stretch. And if it's between 0 and 1, it's going to be a shrink. The next one we have is a horizontal stretch or shrink. And that is a little bit different. You have to think of that as 1 over the value. So in other words, if we have 2 to the 1/5 x, 1/5 is actually going to be a stretch of 5, a horizontal stretch of 5. If we have just a value of like 3 there, that's going to be a shrink by a third. So that one's a little tricky. That's definitely one of the ones that sort of, has you thinking, but we'll do a lot of practice and you'll see what I mean. Then we have reflections. We have a negative in front. That's going to be a reflection over the x-axis. And if we have a reflection right with the x, if we have a negative right with the x, that's going to reflect over the y-axis. So the best way to really understand these is to start looking at them and graphing them. We have our parent function 2 to the x. We have a 1/2 out front. That means we're going to have a vertical shrink with this function. And then we have a vertical shrink, and we're going to be reflecting it over the x-axis. So let's take a look at these graphs. We're going to go to our calculator, and we're going to put in y equals 2 to the x power. And then we're going to look at our table of values for -2 through 2. I'm going to set my table, and I think this is an important first step whenever you're going to look at your table. You're going to go to second window. And since I want to look at starting at -2, I'm going to put a -2 there. And I want my table to increment by 1. So make sure your table is set up this way. Now we're going to go to the table, second graph, and we'll look up those values. So we're just going to copy those values into our table. And then we're going to go ahead and plot those values and draw this graph. All right, so we have graphed here the parent function y equals 2 to the x. So let's see what happens now when we put a 1/2 in front of there. And like we said, 1/2 in front is going to be a vertical shrink. That means vertically up and down, we're going to shrink by a 1/2. So let's sketch that graph and see what that really means. We're going to go to y equals, and we're going to enter the function. Once we have the function entered, we're going to go to the table. Now we're going to copy those values into our table. And then let's go ahead and sketch that graph. And you can see that this graph has actually shrunk vertically. So going up and down on the y-axis, it has shrunk, right? Now let's take a look at the last one. We've got a negative as well as that 1/2 out front. So we have a vertical shrink by a 1/2 and a reflection over the x-axis. Okay, let's put that in our calculator and look at that. Go back to y equals. All we have to do is insert a negative. So I'm going to do second delete, that's insert, and make sure you use the negative button, not the subtraction button. All right, we're going to go back to our table, second graph. We're going to enter in those values. And you can see that's we've just negated all the y values that we did for the middle graph. We've taken these values and we just put a negative sign in front because of this reflection. And let's go ahead and sketch that. And now we can see what we mean by reflecting over the x-axis. So we took this blue graph, we put a negative in front, and we reflected it over the x-axis. And we had a vertical shrink, so we still have that, but only reflected. All right, let's take a look at some more. Notice on the graphs of exponential functions that as x gets smaller, in other words, so we have x is -1, -2, etc., the graph of the function gets closer and closer to the x-axis, but never touches it. This means we have a horizontal asymptote at the x-axis or at the line y equals 0. And that's when we have a horizontal asymptote. A horizontal asymptote is a horizontal line that a curve approaches as it heads towards infinity. So if we go back and look at these graphs here, these graphs, the red graph and the blue graph and the black graph, all of them were approaching this asymptote that we didn't really talk about here, but I will sketch it in now. There was an asymptote right here at y equals 0. And since we didn't move the graph up or down, we kept our asymptote at y equals 0. So that asymptote would only shift if we have a vertical translation up or down. So I'll show you what I mean. Complete the table on the same set of axes, and then this time we're saying be sure to include your asymptotes. All right, so we have our parent function 2, 3 to the x. So let's graph that first. Go to y equals 2 and 3 to the x. Go back to our table of values, and we're going to plot those points. All right, so we can see from our graph that we have a horizontal asymptote at y equals 0. If you're really not sure about that, you just want to decide, do you have a vertical translation or not? We're not moving the function up or down, so our horizontal asymptote is at y equals 0. And if we were to look at the table of values and just start looking at what's happening to the x values, all right, so as we say at -1, we're at 0.6, then at -2, we're at 0.2, then at -3, we're at 0.07. You see, we're getting closer and closer to 0, but we're never going to touch 0. So that means that we have that horizontal asymptote at y equals 0. All right, now, if you notice with the next graph, we have that +1 with the x. So that +1 with the x means that we're going to move the whole graph left 1. Does this affect the horizontal asymptote at y equals 0? And that would be a no, because we're just moving the whole function left, so we're not moving it up or down, so it doesn't affect the horizontal asymptote. So we're going to go back to our calculator and put that in our y equals. And we're going to make sure that we have the +1 is with the exponent. When in doubt, use parentheses. We'll go back to our table. We want to look at the value of -2 through 2 again and copy those in. Right, we'll draw that graph. And you can see that from the red graph to the blue graph, we just did move the function over left 1, and the horizontal asymptote remained at y equals 0. Now the last graph, we have that -4 on the outside. That means the whole function is going to move down 4. That means that our horizontal asymptote is going to be at y equals -4. So when we draw the graph, you'll see what I mean. So let's go back to our calculator. This time you'd use a subtraction. Make sure it's subtraction and not a negative because we're actually subtracting 4. We're not multiplying by negative 4. That's important. Go back to the table, second graph, and we'll copy in those values. Sketch the graph. And this time you can see that our asymptote has moved down to y equals negative 4. And again, if you're not sure, you could look at the table of values and you can see that as we're at negative 1, we've got negative 3.3, then we're at negative 3.7, negative 3.92. And you see we're getting closer and closer to 4, but we're never going to quite hit 4. Right now, even if your calculator says we hit 4, your calculator at this point is rounding. So it's a lie. You can't believe it. Right? We never actually touch negative 4 for that graph. So we have the parent function is y equals 2 to the x. And this time we put a half in front of the x and a minus 1 on the outside. That half in front has to do with either a horizontal stretch or shrink. Since it's 1/2, in this case, it's a horizontal stretch by 2. And if you're not sure, you can always use that table that's on the first page of the notes for your reference. Right, that takes care of the 1/2. The minus 1 means we're moving the function down 1. For letter B, we have x plus 3. The plus 3 is with the x, so that means we're moving the function left 3. For part C, we have a negative in the front. That's a reflection over the x-axis. And we also have that 4 there. That 4 means that we have a vertical stretch by 4. The 1/3 in front means we have a vertical shrink by 1/3. The x minus 1 means we're moving the function right 1. And the plus 1 on the outside means we're moving the whole function up 1. Right, for number 4, it says, write the equation for the function that results from each transformation applied to the parent function y equals 5 to the x. So I would suggest pausing the video here and trying these on your own and come back when you're ready. If we're moving this function down 3 units, we're just going to put a minus 3 on the end. This time we're moving the function 2 units to the right, and we have a horizontal shrink by 1/3. So that's going to be y equals 5. The horizontal shrink by 1/3 means we have a 3 in front of the x. We also are moving the function right 2, so we have a 3 in front of the x minus 2. Make sure you use parentheses with that one. Reflecting over the y-axis, that means we're going to put a negative in front of the x, not in front of the whole function. If it was over the x-axis, we would have our negative out here. But because it's in front of the y-axis, we're going to have our negative here. Reflect over the x-axis, that means we have a negative in front, and we also are stretching it vertically by 1/4, which means that 1/4 is also going to go in front. Okay, so number 5, sketch the graph by using y equals 2 to the x as the parent and applying the transformations. All right, so we just want to note really what's happening here. This negative in front, that means that we're going to negate all the y values. We're going to make all the y values in the parent function become negative. This minus 4, that means we're going to move the whole function right 4. Means all the x values, we have to add 4 to all the x values because we want to move the whole function right 4. And this plus 3 means we want to move the whole function up 3. All right, so let's graph the points for the parent function. We have these points from the first page, so I'm just going to copy those in. And we know with this function that the asymptote is going to be at y equals 0. We haven't moved it up or down. So let's graph that. And like you've noticed, I've been putting in my asymptote like a dashed line. So we want to label that as y equals 0. And this is our function y equals 2 to the x. Now, without using our calculator, we're going to go ahead and transform these points. So we know we're moving our whole function right 4. So that means that we're going to take all of our x values, and we have to add 4 to all of those values. So we have -2 plus 4, that gives us 2, -1 plus 4, that gives us 3, 0 plus 4, that gives us 4, 1 plus 4 gives us 5, and 2 plus 4, that gives us 6. We know because of the negative out front, we have to negate all the y values, and we also have to move all the y values up 3. So we have to add 3 to all the y values. So we're going to negate all the y values. So I took these values and I just put negatives out front, and I also have to move it all up 3. So I'm going to add 3 to all of those. All right, let's plot those. And remember, because we have a vertical translation up 3, we're going to have a horizontal asymptote at y equals 3. Might be helpful to draw that in before you sketch your graph. All right, so that's all I have for this lesson, everybody. Thanks for watching. Have a great day.